watch it offline.
Perfect. Thank you, Roberto. I just
Okay.
started. Yeah.
Okay.
Good morning, everyone.
Good morning. Let's wait 1 minute and we can start. Are you already recording, George?
Yes, Roberto, I started the recording.
Okay, thanks.
You're welcome.
So, I don't know if Lucia is connected.
Yes, Roberto, I am connected.
Okay, okay. So let's start. I will do a small introduction and I will pass the ball to my colleagues, which are more expert on asset administration shell. I'm here with Lara, which is here with me in the room, and Lucia is in remote. And they are both working a lot on asset administration shell. And the objective of the workshop is mainly for everyone to understand what can be done with what is asset administration shell, what can be done with this technology, and the objective is to help in the development of Work Package 3 with integration of asset administration shell with 5G. We have some content on that, and also the work we have to do to integrate OPC-UA with asset administration shell in the Work Package 4, and also to integrate with the to see the possible integration or usage of asset administration shell in the 499 standard for the Work Package 5. So we also have some information or proposals on that or options on that lines. So I will pass the ball now to Lucia, no? Or Lara?
To Lucia, but I'm going to download the presentation. Please 1 minute.
But Lucia can start, no? With the...
Sí.
Okay. So Lucia, please, if you want to share the screen and...
No, Lara will share the presentation because then it will show the Package Explorer.
All right, all right. So Lara is opening the presentation and she will share the screen with you. Toda la screen. Si luego vas a abrir el Explorer.
Okay. Okay, can you see my screen? The presentation?
Yes. Yes. Yes.
Okay, perfect. So first, good morning to everyone. We are going to talk about the asset administration shell. And today, this is the content that...
What happened?
We lost the presentation.
Now? You can see, I don't know what's happened here. I'm sorry, I'm going to change. Okay.
Now perfect.
Yeah.
Going to...
Ciérralas. No lo vemos nosotros.
Okay. Okay, so this is that we are going to talk about. This is some points. At the end of the presentation, you can also ask the question that you have. First, we are going to explain something more, the theoretical part of the asset administration share. And in the last part, we are going to make some examples and deploying easy examples with software that can be used to model and asset administration shell. Okay, so let's start.
Okay, so as a short introduction, in Industry 4.0, we follow the RAMI 4.0 reference architecture. This architecture takes in consideration the main 6 layers, the vertical axis, in which we go from the asset level to the business level. And also this architecture is a service-oriented architecture which defines what is a Industry 4.0 component. Industry 4.0 component is the asset and the digital models that describe the asset. And this is the digital twin. And this digital twin is what we call asset administration shell. And as a reminder, an asset is anything that is valuable for the company. It could be something physical like a machine, or digital like a software, or human. Okay, next slide, Lara. No, yes. As I mentioned before, the asset administration shell is the digital twin for Industry 4.0. But nowadays, we have a lot of definitions or understandings about what is a digital twin. This cube represents the multiple definitions of a digital twin. As you can see, we divide them in taking in consideration the hierarchical levels, the common use, and the life cycle phases. In the case of the asset administration shell, we could consider our asset in the level of the product, process, system, and the common use used to be digitize or orchestrate, and can be used in all life cycle phases. And now Lara will explain the AES modeling. Lara, I cannot hear you.
Okay, sorry, we
were muted.
We muted. Okay, thanks. So I will start again. The asset administration shell, as the digital representation of an asset, is structured in 2 parts, the header and the body. The header contains the minimum information to identify in a unique form the asset and its digital parts. The body contains information about the asset. This information is organized in submodels, which each one defines a specific aspect of the asset. The asset administration shell is implemented through a generic standardized interface called metamodel. The metamodel describes the structure of an AAS. Yes?
Just a small question on the previous slide, and I hope this would be the last question I will, because I know that we have a lot of partners coming from different backgrounds. It would be nice if we can at least give a small example or a short definition of what do we mean by asset in Industry 4.0, let's say, framework. So just maybe. So then people could understand what does it mean representation of asset information in header, what does it mean the body, and so on. So just maybe one example or a small definition.
Put one comment. Just
sure.
We were talking that all questions are welcome.
Okay,
if they are
later. Okay,
cool. So everyone can follow. It is better than not questions, maybe discussions about the project, but just about the slides and so on.
Okay.
So everyone can follow. So please do as much as you want.
Okay.
Thank you. Can you?
Okay, about the asset administration shell, as Lucia has said before, is the digital twin of an asset. Okay, now when I talk about the header and the body, is something that how is the file, as you can say, divided, but it's not something that if you want it when you are going to deploy the asset administration shell in an instance, you don't need to focus on that. Okay, so that's not a really important thing. This is only some information that you will know that, okay, it has 2 parts. Some information about, for example, in the header, you have, when I say the minimum information, it's like the identifies and something like that. And in the body is all the information, the model and the properties. Maybe now it's not clear because I have to talk about the models and things like that.
But
that is the problem. That is only, this is, okay, the structure about the asset administration shell, but no, okay, it's fine, you said. Okay, perfect.
But the question was also what is an asset, no? And it can be
An asset,
anything of value for the company. No, you can select the
yes,
level of.
As Lucia said, an asset is everything with value for a company.
It could be a resource, an AGV. It could also
Yes.
be an operator or not.
Yes,
Yes,
it could be
yes.
anything.
Anything. Okay, thank
Can
you.
be physical like a machine, or digital like a software, or human, a person.
You are the one to select the level from the robot to the screw level. What is the level of modeling that fits your purpose? But it can model everything, even a person.
So I don't know if that's clear, or if anyone has.
Thanks a lot. I think that's perfect. I'm sorry for the interruption. I think it's better to keep on and then keep the questions for the end because then things would be clear. So I will keep it quiet. Thanks.
Okay, no, you're welcome, Puria. Thanks. That's the question, is that because you were interested in that, so your questions are welcome. Okay, so let's keep on. Okay, so the metamodel. Okay, the metamodel is the generic standardization interface which implement the asset administration shell. What the metamodel describes? It describes the structure of an asset administration shell and its submodels, describing the elements of the submodels with its meaning. Also, if you want more information about the AAS metamodel, it is defined in the details of the asset administration shell part 1. In the PowerPoint, there is a link here, and you can go to that document that is in the platform, if platform Industrie 4.0, and you can have more information about it. So the metamodel also is technologically neutral, and it can be serialized like in different formats, like XML, JSON, or OpenSWA, for example. Also, there is a special serialization called asset administration shell, which contains serialized information in XML or in JSON, and additional files of the AAS, like an instance of PDF or image or whatever you want. There is serialized instance of an asset administration shell can be stored like files to be used in application or also to be shared with another partners. So the submodels. The information of an asset is sorted in a tree of submodels. A submodel structures the digital properties and functionalities of an asset that have in common a well-defined domain. Also, the submodels can be standardized and represented in a template form. Here, in the presentation, you have a link to the EDTA page where there are some submodel templates defined. The assets are identified in the asset administration shell with a unique ID. This identification distinguishes element of an asset administration shell and its asset in a unique form and enable relations with external definitions. So, this is important. An asset represents an AAS represents exactly one asset with a unique ID.
Who selects this ID? Can a company select their own IDs,
yes,
or they are standardized?
The ID can be defined. There are some rules can be defined, like a URI form. or for example, like with a ERD form also, but also there are some ID that can be make it customized. But the only thing that you have to do is to be sure that they are unique. So this is the name.
So there are different formats?
There are different formats. The different formats using the ID or the URI is to be sure that they are IDs in globally unique.
But are there some IDs already defined in the asset administration shell standard? For example,
No.
Some IDs that I cannot use?
No, for now, no.
So for my implementation, I can select any
Yes.
IDs system I want. Okay, thanks.
Okay, something also important is the semantics. Every submodel or property needs a semantic definition to have a well-defined meaning. So every user of the asset administration shell will know the meaning of it in an ambiguous form. Enable the increasing the interoperability between different components. The semantic definition can be provided by an external definition, for example, e-class or EAC, or with a content description. That is something in the asset administration. Now, the types. This is something important. The asset administration shell can be classified in function of the different ways that it exchanges the information. So we have 3 types. The AAS of Taiwan are the passive AAS, like a serialized file, and contains static information. These files can be shared between partners in a form like files with email or something like that. The AAS of type 2 are the reactive or active AAS, and instances are hosted on servers, which enables the access to the properties, operation, or events through different protocols like RESAPI, MQTT, or OpenCUA. And the last one, the AAS of type 3, are the proactive asset administration shells, and in instances are hosted in a server application, which enables the interaction between the AAS, being able to communicate and negotiate on its own using the Industrie 4.0 language.
Can we give an example of each type?
For example, the type 1 is
I've seen
a file, for example, a machine that don't have any communication with that you can communicate. Shell, if you want to model a table, for example, like an IAS, it will be of type 1 because you can't communicate with it. It doesn't have inputs, it doesn't have outputs. A robot nowadays are an administration of type 2 because you can interact with it, but nowadays it don't have the capability to modify or to negotiate with another assets some information. And for example, software, you can have a software that communicates with some AAS, and if a software that controls the process is like a type 3, because depending of some inputs, it will modify the parameters to make the control. So it will change the properties of another asset.
Can I make a comment? So, just it may help you. Most of examples of asset administration shell in different courses we had are only the type 1. So the companies were type 2.
Type 1 and 2.
Okay.
Nowadays, type 1 and 2, the type 3 can be nowadays assets more like software.
So type 1, for example, I've seen companies that they put a QR code in their product, for example, and through the QR code, you access to the documentation of this product, which is in a server in the company, and this server is organized using the asset administration shell. So they are like documents just to store information and organize information. For example, the asset administration shell then has links to PDF for the product, image of the product, and so on. And then the other two are like the active ones, which go embedded into devices. For example, a robot or a camera would be type 2. You can access, maybe read the asset administration shell to get information, or maybe use the asset administration shell to configure a set of settings in the device. So it's kind of a slave in the master-slave point of view. And the type 3 would be like an intelligent device. Okay, I want to manufacture something. Then he's intelligent, selects the proper asset administration shell and configures the robot, for example, with a specific asset administration shell for that tasks. I think this is important. I don't know if you have more questions, but I think it's important to make the difference to understand what type of asset administration shell is better for 5G, edge computing, and so on for the different applications.
Sorry, one comment. For me, it's very interesting. I think it's very important, as you said, to understand the differences between these three types of AAS. But to better understand, do you know if there are some examples that we can see to better understand the differences? Do you know if we can find some examples of these?
We will give later examples of type 2 and type 3 in a real implementation.
Perfect.
The type 1 is just to use the asset administration shell to organize some documentation. And the other two is like, I see them like type 2 like a slave and type 3 like a master that has intelligence to say the type 2 asset administration shell what to do. You know? I don't know if this is clear. For example, a robot or a camera or a device is a type 2. He's like, let's say, stupid, and you just configure some settings. And then the type 3 would be some intelligent software, production software, manufacturing software that uses the asset administration shell to configure different devices depending on the task they want to accomplish.
Okay. Yes. I think that the idea is clear, but I don't know if we can see some examples.
Yes, at the end of the theoretical part, we will show a practical part.
Okay.
We will make some example, and then we will show the asset administration shell of a robot. That is type 2.
Yeah.
Perfect.
Let's continue, and maybe in the end, if you have more questions, because some of them may be answered during the presentation.
Thank you very much.
Okay, here also the types are defined, and you can and you have some links, to the documentation. Okay, now so this part, my partner Lucia is going to talk about it.
Okay, now we change the topic to explain the PPR concept. The PPR model is the basis for implementing the plug and produce or plug and play concept using asset administration shell, and for implementing the type 2 and type 3 asset administration shell. So the main assets in a production are the product, the process, that are all the activities that lead to the product, and the resources, all the assets needed for executing the process. I will explain this graph from the point of view of the manufacturing, because I think it's the easiest way. So I have a product that I want to manufacture that requires a service. This service provides some capability. The process needed for the manufacturing of the process requires some capabilities, and the matching of the capabilities that the software requires and the service offers are the ones that define the resources that I need. And these resources provide the capabilities needed in a form of skills. So this concept led us to the capabilities, skills, and service model. So Lara, if you move to the next one. This one.
Next.
No, this one.
Okay, sorry.
The capabilities, skills, and service model, we will use it later in the example of the Type 2 and Type 3 AES. And as I mentioned before, is the basis for modeling. A capability is the abstract definition or description of an operation. For example, in the case of a robot, the robot has the capability to move. Okay, the skill is the implementation of this capability. In the robot, the capability move has the skill that could be moved from this point to this one with this speed. And a service are the operations that the market offers. And Lara, go to the next one. Yes, capabilities.
Sorry, just one question on the previous slide, just quickly.
Yes.
So for every, the other, yeah, this one. So for every single asset, you need to produce, to kind of list a skill, capability, service, and PPR, or is this one for collective of assets? So
for the asset, you have to define the capabilities and skills.
Okay, capability and skills are mandatory, let's say.
Yes, for implementing the Type 2 and Type 3 asset administration shell.
Okay, thanks.
This is an application of asset administration shell for the, how did you call it, Lucia? Plug and produce? Or?
Plug and produce, plug and play concept.
So you have like a product that to be manufactured demands some capabilities, and they define how to call the capability. Well, sorry, I don't not able to explain.
I understood. So, but because the example that she provided was quite clear. So, bare minimum is capability and skill, like the capability of move and the skill to move from A to B in a, I don't know, a certain way. Yeah.
And the service, Lucia, I didn't understand quite well.
The service could be manufacture this product. The service is a more complex concept that nowadays we are not focused on that. And in the next topics that the European Commission is proposing, we will focus on the concept of the manufacturing as a service, and we will have to implement this kind of modeling. But now I prefer only to focus on the capabilities and skills because for me are the important ones for the applications that we are focused on.
So these are like different levels to explain what an asset can do. Okay, thanks.
Okay. Yeah, capabilities. As I said before, is the abstract definition of an operation. But what is important is that the capabilities are the ones that help us to orchestrate the process and can be executed via services. The resources has some capabilities, but these capabilities are independent of the process and the product that can be used, these capabilities. In the example of the robot, okay, the capability could be move, but also could be communicate. This is also a capability. Lara, go to the next one. Yes. And the skills are the implementation of the capabilities on a specific resource. I think the example of the robot is clear with the capability move, but for example, with the capability of communicate, the skill would be, so I will communicate using this protocol I need this IP, this port, and this is the data format that I use for the communication. Okay. Later we will see an example of real example in the Package Explorer. And the service, what I commented before, is that in these projects, ZeroSWARM, we will not focus on this part. But only to say that the service will require the capabilities that the resources have to execute the process. And this concept will be used in the next projects for implementing the manufacturing as a service concept.
Okay, so now that we have finished the theoretical part, the tough part, we are going to the practical part. So how we model an asset administration shell. There are 3 steps. Well, technically there are two steps, the phase 1 and phase 2, but we have added the phase 0 because we think that it's an important phase, a step. Okay, so we have 3 steps in deploying the asset administration shell. The first one is the definition of the asset and gather its properties. Then you have to structure all the information of the asset using the AAS metamodel. And the last part is to define the communication of the asset with the external elements with the Industrie 4.0 language. Okay, so let's focus on each phase. Okay, the first step. In this first phase, the information which is going to be digitalized in an asset must be gathered. First, you need to define the asset components which are going to be represented. If the complex of the components is high, they can be represented as an independent asset administration shell and can be incorporated like an asset administration shell in it. The granularity of the representation will depend on the information which is going to be represented and the view of the deployment. For example, somebody who needs to obtain the position of the robot will represent the robot in the asset administration shell like a common structure, the robot itself. But for someone from maintenance, for example, will prefer to divide it in motors, encoders, and sensors to have individual information related with the preventive maintenance of each element. Once you know the architecture of the asset, you must define the information that is going to be digitalized and classified. So you must ask yourself, what are the purpose of the asset? Where is the origin of the data? Is the data at rest or is in motion? What are its capabilities? What can the asset offer? Once you have finished this phase, you will have a draft which all the information of the asset is needed to be digitalized. And you pass to the second phase. In this phase, all the information which was gathered in the previous phase has to be implemented using the asset administration shell metamodel standard. If some information of the asset is defined by any standard, the properties of the submodel, which represent this information, must contain all the data that the standard defines. At the end of this phase, the asset is going to be modeled as a passive AAS, as a type 1. And it is not necessary that the asset in this phase has to be completed or technically correct. You can complete it before. So the last phase starts with a question. Does the asset exchange information? If the answer is no, the modeling is complete and the asset is of type 1. For example, if you are modeling a table, something, this table don't communicate with another one. So it's a type 1. If the answer is yes, the information which is needed to exchange the data must be defined using the Industrie 4.0 language. Once you have implemented this information, you need to ask yourself, does the asset interact with another asset and modify its properties? If the answer is no, you have an asset administration shell of type 2, and it must be hosted in a server with a REST API, OpenCU way, or MQTT communication to enables this communication. If the answer is yes, you have an asset of type 3, and it must be hosted in a software which enables the communication and negotiate with another assets. Okay, so let's go to the technical part.
Practical.
Practical, sorry. Okay, let's show the Package Explorer. Okay, this is the AAS X Package Explorer. This software enables to deploy an AAS using a visual interface to modify or create well, everybody can see the Package Explorer, no? Yes.
Yes.
Okay, so to modify AAS or to create a new one, first you need to click on the workspace and enables the edit.
Just one silly question. Is it something that you developed, or is it something that Industrie 4.0 platform developed and people can download?
Yes, you can download it in here.
Is the link in the presentation?
This is the link in the presentation in GitHub. You can download here.
You developed it, right? Or you're also part of the contributors to the?
No, we are not contributors.
Okay, we are not contributors. Okay.
Yes, this is something that is developed. We wanted in the project, we have to develop an AAS toolkit. So we are going to deploy some other software because we have worked with that software, and we have found a lot of problems. So we want to solve that problems because this software doesn't fix with the standard very in all the parts. So we want to improve that.
Is this project alive, or they are updating every day, or it is
every day? No, but for example, this version was released
2023. Okay.
And the last version was released in August of last year. Okay, so you can download from here, and you don't need to install to work with it. It's like an executable file. Okay, so once you have select the workspace and edit, you will have a 3 of different nodes. In this node, in the asset administration shell node, you can add the different digital twins of the assets. In the asset, you can add the physical part, the asset. Here, in the submodels, there will be defined all the submodels that are defined in the different asset administration shell. And in the concept description node is where you can add the semantic descriptions to be related with the properties and the submodels of the asset administration shell. Last, in the supplementary files, you can have all the files related with the asset, like document and thumbnails. But this is the image that will be appear here if you add.
Can you say where is the header and what is the body of the asset?
This is not the part of it. In the header,
this is the body, or
no? This is a visual interface. Okay.
Okay.
The header.
The header is not shown here, no?
No.
Okay.
The header, you can see it in the AASX file.
When you open the XML.
Yes.
Okay.
In the header, you will have the information of the asset with its ID.
Okay.
sorry. That is what it's shown in the file. And in the body, there will be the description of everything that you put here.
Okay, thanks.
Okay. So, okay, let's start. First, like the asset administration shell is the join of the digital part and the physical part, the first thing that you have to do is to add the physical part. It is known as the asset. So let's add the asset. So we select the asset nodes and an asset. Here, the important field that you have to define is the identifiable, that is the unique ID. In this case, we are using the type custom, but as I said before, it can be like defining like a IRI or like a IRD. So we will rename, for example, I know that it must be unique, but this is a silly example. So we will set the ZeroSWARM asset. And in the ID short, this is the user-friendly identification. This is not unique and is for the user to be more easy to refer to the asset. So we call asset.
It's like the display name, no? Or something?
Yes. Now we have to save it. And the end, okay. So we have the asset. Now that we have defined the asset, we can define the digital twin, the asset administration shell. So we are going to add the asset administration shell. Let's add the asset administration shell. As in the asset, we have to identify it in a unique way. So the ZeroSWARM AAS and put the ID short or friendly name. So this is the AAS, for example. Once, as I said before, the asset is the join of the physical and the digital part. So we have to add this join. So in the asset reference, we add the join to the physical world. So we relate the digital part with the physical part. This way, as you can see here, we have the AAS of the digital part, the AAS of the physical part, the asset.
So you can have more than one asset administration shell for the same asset in the same file here?
As I said before, one asset administration cell represents an unique asset, but an asset can have different digital twins, depends of the view of you want to represent.
So I can have asset administration cell for maintenance, asset administration cell for
As
robot developer.
Yes, because the asset administration shell, as Lucia has said in the second slide, is the representation is the cube. So each asset administration shell is like a mini cube in the big cube.
Okay.
So you have the asset administration shell. Now we have to structure all the information that we have gathered in the step 1. So for this, we have to sort this information in different submodels. So now let's add a submodel. Let's create a new submodel kingdom instance. Now we have a submodel. As the asset and the asset administration shell, the submodels must be identified with a unique ID. In this case, we are going to change, because this is a difficult name. In this example, we are going to change it to custom rename. So ZeroSWARM submodel identification. And we have to say also our easy name. So this submodel will be the identification submodel. Now that we have the first part, in this identification models have all the properties that are related with the identification of the asset. For example, the name of the asset, the manufacturer company of the asset, its serial number of the asset, every information that identifies it. For example, if you have information about the inputs of the asset, like the set points and something like that, all the set points have to be in another submodel. That will be the input submodels. So let's create a property. The property is an element of the submodel. So we go to the submodel elements, and maybe we can have other property, or in other, we have the different elements that can be added in a submodel. So let's select the property.
A property is like a static variable.
It's a parameter that defines. For example, a property is the name. The name of the serial number is a property. Okay. It's an attribute of the asset. So the properties have to be identified with the ID short. So let's put the ID short. For example, in the identification, you want to identify there is one property that is the serial number. Serial number, which is a property, is a constant. Serial number doesn't change. And now this is really important in this administration shell, like in OPC way, you have to define the type of the property. This is a string. For example, if you have in technical data information, if you have the payload of the robot, the payload will be for an integer or a float, a number. So we can put the value. So the serial number of this AAS is 1, 2, 3, 4, 5, 6, 7. Also, if you want to add the semantic information, here you can add the relation, add no if you have is concept description defined, or ID class if you know the ID class. Okay, so once you have saved it, the values will be shown here. Now let's show, for example, this is the as administration shell of a robot. This as administration shell is of type 2. Here in the robot, you have the identification submodel with all the information that identifies the asset, like the name, the model, the version, the serial number. All the information that identifies the robot is in the submodel element. The technical data, here, for example, you have the axis number, the weight, the maximum speed. This is parameters that are technical. So they are gathered in the technical data. And now Here we have the capabilities, the submodel capabilities. Here, as Lucia have commented before, we have the capabilities of moving and to communicate. These capabilities are related with the skills. The skills are represented, for example, here is the skill of communicate, and in this element relates the capability of communicate with the skill of communicate. For example, in communication, we have the skill implemented here. We have the communication capability without any implementation. And in the skill, we define that the communication is through Ethernet, is the type of internet. And we have also another submodel that is for that gathers all the information that we need to realize the communication through Ethernet. Like, for example, the IP, the port, the format, and things like that. In the last part, we have some models of the inputs and the outputs of the asset. The outputs of the robot is the position and the speed of a state. For example, in this case, the parameters are the TCP ports. So this is an example of a type 2 AAS.
Parameters are the inputs and operational data the outputs. No?
Yes,
okay.
The operational data. These names are, for example, this is a name selected by the standard. The submodel that defines the outputs of the asset are in the submodel, which ed short has to be operational data, and the inputs has to be sorted in a submodel, which ed short must be parameters.
So the standard defines some submodels, but you can define your own too.
Yes,
no?
there are submodels, standard submodels with the name. Logically, the properties of the inputs or the outputs will depend of the asset, but the name is something standardized. There are some other submodels that are not standardized because they depend of the asset. Like, for example, the way to communicate with Ethernet to connect with the robot. Okay.
Sorry, just maybe it would be nice to spend a few minutes here for some questions, because I saw some people they did hand raise.
Okay, sorry, I didn't see.
Yeah, and then I think there would be like a lot of maybe not a lot, but just some questions here. I don't know if I forgot who was the person.
I raised my hand, and I had some question about the standardization of this section of data, but I think that the answer came during the discussion that some of the sections are part of the standard, and some can be customized depending on the asset. What I was going to ask is how much is the standardization on this? Because I see that the data model is very flexible. I mean, because it's made to describe assets of very different types, and so it's a quite flexible data model. But for example, the identification section, it's mapped in the standard, all the fields that it must have. It must be present every time. So if there is a standard reference for the parts which are mandatory, and where is the standard described in that case, if there is a standard.
I will answer, Lara. Yes, there is I don't know if it's a standard, but The association that is related with asset administration shell is IDTA, Industrial Digital Twin Association. These associations publish some submodels templates that could be the identification submodel with the information or the parameters or properties that has to be included. You can download this information in the web page of this association and use it as a template of your submodel. Here we are not following the IDTA template, but we should follow this one.
Okay.
Maybe just
Let me
a
check the
similar-
link.
Because the standard only defines the data model, no? And then you can the tree structure it's more free, and you can decide if using the templates or no, or invent your own ones for your implementation.
Yes, the AAS standards defines the structure, because at the end you will have there are assets that will need some models that are specifically. So this is what defines the standard: a structure in common.
Mm-hmm. And do you know if there is any standard or anybody that is looking into the communication part, for example? Like, because here I see that we have the Ethernet, and then below we have the configuration of Ethernet. But I was just wondering if there is any particular entity.
Later we have some slide on that. No?
Yes, but one comment. We know that this association is working on a submodel for specific communications like OPC UA, but not in a communication submodel. But we found some papers that they also model this communication submodel, and what we found is related with 5G. We have a slide with this information.
Mm-hmm. But as far as you know, there is no, let's say, reference standard, let's say.
No.
So there is
no at this moment.
Okay, good. And just another, let's say, similar question is that, let's put it like, so as far as I understood, this is more like an asset administration. It's like type 2, right? Because it's like an asset that you can also receive some information or updates. Kind of, there is an interaction, or it's not like a table, right? It has a exchange of information. So
type 1, no, robot.
No, robot is type 2.
Type
but
2.
If you can use this asset like a type 1, if you only send or use this as administration shell like a file, it's type 1. But if you host this as administration shell in a platform that enables the as administration shell to communicate using MQTT or API REST or some protocols, it will be type 2. Okay. No, it is type 2. You will have you will give the AAS the abilities of being type 2.
Okay, so exactly this is my question. Let's say, how can I put it to be clear? So who would be the end user of this? So could it be just a person that is sitting in I don't know, in an office and looking at these numbers, and if something goes wrong, the person
type 1, no? If you just use it as a documentation.
If it's only use it as a documentation, you will use the AAS of type 2 like a type 1.
Oh.
It's like the example.
Use like a documentation, like a configuration file.
Like the example I gave before, a company that puts a QR for a person, and then this QR goes to a website that is organized with the asset administration shell on the background. Now, in this way, you are using asset administration shell just a way to organize your documentation of all your assets and products of your company. So this is the type 1. And
now
in this way, they are using it to communicate with a robot and try to do a plug and produce. This is the type 2. No?
Okay. And okay, plug and produce, I understand, but so it means more getting integrated with the other assets that exist in the same maybe shop floor, At the
Yeah,
same time, doing some dynamic changes. Does it also include dynamic changes back
Yes.
to the asset? Okay.
Yes. Later, they have a full example of
Okay.
how they use it for the plug and produce, and you will understand, because I had the same doubts of you as after I saw how they implemented it. So.
Okay, so there is another question.
Yeah, hello. I have two questions, and they're all about automatization. Maybe I didn't catch something, but here you create this asset manually. And are there any approaches or tools when we, for example, when we have interface of well, I don't know, maybe of a robot communication interface, and we can infer it or generate somehow this administration shell for it, or backwards, if we have administration shell, for example, we can we translate it to well, executable code description of interface or something like that.
Yeah, this is one of the parts of the work package 4, maybe 5,
cool.
which is to use the asset administration shell inside an edge computing platform, and our purpose is to use it as a way to instantiate complex processing pipelines and also configure it. So to instantiate software blocks, interconnect them, and also put the configuration of these blocks. So we want to use the asset administration shell as a standard way to configure how this edge device should behave. We will show later, maybe.
Oh, okay,
But
sorry.
you can use it in different ways. You could put it inside of the asset and ask the asset, what's your asset administration shell, and it will give you the information, or you can have it outside and send it to the asset to configure it. It's different ways.
Okay, thank you.
Sorry, Roberto, Fernando from Visuals, if I can add something.
Yes, please.
From our side in the digital simulation, all the components that are virtual, they are like assets. So we have the metadata. So for us, it's a data model. So that through our API, we are able to formalize that metadata in different formats. So in that way, we can formalize in a way that later you can import in the reader of the asset administration shell. So and the same bad words. Basically, we can import, but we rely to have assets. For example, if one of the assets has one link to one cat, we rely to have access to that cat. So in that way, we can use from getting information out of our tool and to bring back. There's another application.
But are you using asset administration shell or other type of data?
No, we are at this moment we are using AML, but AML is covering another kind, like the topology. But there is now an understanding to also add the part of the asset administration set. At this point, we are not using, but we can implement that kind of data model.
Yeah, I think the point of this meeting is to understand and maybe evaluate if it's useful for our applications.
Yes, the asset administration shell and the AIMEN automation ML can be serialization. If you have an AIML, you can easily change to asset administration shell. And in the other direction, it's also possible.
So they are easily compatible if you want to make tools to transform and so on. Yeah, okay.
Yeah, there is an understanding between OPC UA, AML, and Industrie 4.0.
Yes.
To have a common understanding and don't reinvent the wheel at the way of developing the data model.
Exactly.
Yes.
Okay, so there is another question. Is there another question? 1, 2. Okay, so maybe we can go to the next part. Okay, so Lucia.
Okay, this is the architecture that we are following for the implementation of asset administration shell. We have a software that we name it Orchestrator. This software gets all the AES models that we have stored in a database or configure the edge devices. And these edge devices start the communication with the devices or the assets and send the information, the real-time data to the initial database where we have the AES models. So we have the AES models updated with the real-time data. So I don't know if it is better to explain the next slide because
I think it's better they
yes.
understand. Maybe I can do a comment on the previous slide. So because yeah, you have this orchestrator web UI, no, which is the
Yes.
user, because the point what they are trying to do is that you want to manufacture something, no, some order of manufacturing enters in the company, or you can do it manually through this web UI. So this orchestrator is the intelligence checks using the asset administration cell what cells can produce this have the capabilities to produce this product, and who cells are free of work, maybe some of them are already working, and then select the correct asset administration cell for this cell to configure it and produce this product. So this orchestrator, this is the intelligence, no? This is like the type 3, takes the models and sends to the correct edge computing. In our current implementation, I think is one edge per manufacturing cell, and this controls like the robot, the camera, maybe some powder feeder, whatever. So initially, the asset administration cells are sent like a configuration of the cell, and then data is traveling also to a database in the cloud, but it could go from the edge computing directly to a display for the worker in the cell, or it can be connected to other types of software through the, for example, edge computing is the software we are currently developing in the ZeroSWARM. It will have OPC-UA as a standard. So any software, PLC, manufacturing software could connect and gather data from there directly. So this is an actual implementation of using asset administration shell. This is one example of how to use it. And I don't know if you have questions on this, because this could be a starting point, I think, for you to think how to use it for your applications and so on. In the next slides, I have a zoom into the edge devices, because currently we are thinking and discussing how to integrate asset administration shell with our current edge computing software. Our current edge computing software is a pipeline-based software that we use to efficiently process images or implement images, artificial intelligence, inference, and other data, not only images. We can connect via Modbus, Profinet to get data from other devices and so on. So the basic is that we have a pipeline, and then we use OPC-UA as a standard framework to read data with other applications, graphical user interface, and to modify the parameters of the different blocks that are in the pipeline. For example, if we have a camera, we can change from the OPC-UA the exposure of the camera, or if we have a software block that makes, for example, by binarization of an image. We can change the threshold for the binarization, for example. So this is what we had, and now in the ZeroSWARM, we are studying how to sorry, my computer was about to die. So in the ZeroSWARM, what we want to do is to use asset administration shell to configure these pipelines live, let's say, because now we do it on a main program, and the programmer has to insert the blocks, connect them, and configure them. And what we want is to use the asset administration shell to do this process live. So we can, anytime we want, we send an asset administration shell via XML or serialized, and configures the system. So these are some questions I wanted to raise to you to think about them, to give maybe other options to make how to use it for maybe the 499 or ABB's implementation, or no, I don't know, to give some ideas, because these are the types of questions that we are doing. Our initial idea was to send the asset administration configuration through a node in the OPCUA server. This node calls some function of the configuration manager that destroys all the pipeline and creates a new pipeline based on this asset administration shell, and also reconfigures part of this OPCUA server. OPCUA servers support dynamic reconfiguration, like dynamic destroying nodes and creating new ones. So this was our first idea. Then, based on our colleagues' implementation, they think on OPCUA just as a communication protocol, like another one. They don't give as such a big importance to OPCUA as we were doing. So they have a standard MQTT interface, which is only used to communicate the asset administration shell. And from there, we will connect to the configuration manager that will destroy the pipeline and maybe the OPCUA server, and create it again based on the new configuration. So this first option, using MQTT for inserting the asset administration shell, is good because most of the cloud tools are based on MQTT and not OPCUA. So it makes it easier for implementing the cloud part. So now we are working on the edge computing software, trying to integrate the asset administration shell. We are still to decide which option we go. And if you have any comments or insights on this side, I mean, maybe previous experiences working with your frameworks you develop. So please, you are welcome to comment this, because yeah, we would like to work also together, no, in getting the best implementation, or the best reference architecture. And then other aspect to take into account is at which level do you model your system. As we saw before, you can have different levels of granularity. You can model from the smallest screw in the robot, and or only model the robot at very high level, X, Y, Z location. So in our model, we have an edge device that implements this type of pipeline and reads data from the different devices, physical devices like camera, robot, and so on. So we can model only the edge, which will be like a manufacturing cell, or we can go more fine granularity and model all the different assets, which will be much more work. No, we have an asset for camera, or we can even go for different cameras. I have an asset administration cell for the I don't know, the camera photon focus MV1, another one for the MV2, or I can have just a common camera model. And this implies a lot of more modeling. And if we want to do this, we can compose asset administration cell. We can create an asset administration cell submodule of type AAS composition and insert one asset administration cell inside other asset administration cell. And another option is the one in the left, just modeling at edge level. So we will model this type of pipeline interface in some way, and then use the asset administration shell just as a recipe that describes, configures, and connects the blocks. For example, maybe using one string or different strings, we can enumerate the blocks inside and their interconnections. So we have to create some pseudo language to do this in instantiation and connection of and configuration of the blocks. We think we are going to go for the first one because the other is a lot of work, and we would like to be more easy to use and flexible software. So yeah, this is all what I had to say. Hope you understand what I wanted to say. That are basically the different options in the edge side. If you have questions, otherwise we go for I think the next is the 5G part.
Yeah, if it's just, if I may just, well, thanks a lot for this explanation. I mean, this is not just like necessarily a very well thought question. It's more like a kind of initial impression. We can think about this later if it's needed. So maybe you can confirm, because, well, let me just first give you a bit of background for this question to better land it. So far that what I'm trying to understand is like how would be let's say the implications of using these different interfaces and modeling levels into the layer down that transport the actual data between these, for example, camera and the screen. And I was thinking how likely it is today that, imagine, the camera would like to send something with a certain number of, let's say, frames, and expect that to receive them on the screen side, right? And then because there is a problem in the network or something, this fails. Is these scenarios could be captured in this, let's say, latest model of asset administration that you presented, like modeling at the asset level, the right bottom one, and somehow the screen says, oh, by the way, you told me that you will send, I don't know, X number of frames in seconds, but now I'm not receiving, or it is out of asset administration shell scope at all. So I don't know if I explained myself.
How do you check this? This will check the receiver or OPC UI client, no, that connects to this is the one that will feel this lack of frames, no? Or
okay, so but it's
a question.
Okay, it's a question. Yeah, I'd just like to see if it falls inside the scope of AAS, it doesn't fall in the scope, or it's a responsibility of another layer that needs to make sure that this connection is in place, or with good quality is in place, or something like that.
I think that it falls in place. For example, if I set the camera, I want to go 20 frames per second. This is a parameter of the camera block. If it cannot arrive, for example, some client connects to the OPC server and reads the images. If these images don't get at 20 frames per second, this could be a problem or the camera, of the pipeline, of the communication, OPC communication. I feel this is hard for the asset administration cell. It should be the client who checks this, no?
Okay.
But the client can have the description on what speed should expect and raise a problem if it's not met. I think it fits if the purpose of the client or one of the tasks of the client is to check this speed. It can be described in the asset administration shell. For example, a submodel that is for checking the quality of the image received and so on.
This should be a capability of the client to check the quality of the communication. That could be implemented like a second task in the software. That is a capability.
Mm-hmm.
Oh, okay. Thanks a lot.
Yeah, so the answer is yes, I think. Yeah. Can you go to the next slide? Okay, Lucia, this is yours or?
Yes, this is only to show you that we found this publication in which they try to map the 5G communication properties in asset administration shell. And they also have this communication submodel that we also show you, but from other perspective. I'm not expert in 5G, so I don't know if the model of this submodel, as it is shown in the slide, is correct. But they divide this submodel in static and dynamic information, and that's all.
Yeah, I think from Puria, maybe, or I don't know who is responsible for this task in the work package 3, you can take a look to this and maybe we can have a further conversation. Yeah, I think it's easier for 5G people to understand asset administration shell than for asset administration shell people to understand the 5G. So maybe you can start trying to match both, or we can do together meetings, or I don't know. Yeah. For us, it's very difficult because we don't understand the 5G, what parameters are relevant, what you know. Yeah.
I mean, just maybe to follow up on that. So the way that I see, and the reason that I asked the previous question is like, for me, there are two different directions. One is like when we said asset, we are talking about human, table, I don't know, like a machine, robot, whatever in the factory, right? So whatever that exists, and probably some 5G items. It could be a modem, it could be user equipment, it could be, I don't know, some antenna, is also part of the asset after all, right? It's something that needs to be somehow reflected. And I think, I mean, my quick impression is that this let's say paper or this study tries to do this kind of like, let me use this word carefully, like statically include basically some items from 5G world as definition of asset in Industry 4.0, so something like that. And this is a very valuable work. I think this is the focus of 3.3. We need to check on that, and yeah, of course, reflect correct parameters and check if it's a modem, if it's a user equipment, I don't know, if it's antenna, because there are different equipments of 5G too, right? So each of them could be considered a property or asset in the factory as well. Maybe also there is another direction, which is more about like the quality of communication itself. For example, the previous question that I asked, like one asset A is sending something to one asset to the second asset B, but in between there is something going wrong. Maybe should we only treat it as so much a statistic, or is it something that can be spotted on the fly and we can renegotiate if it's needed? Because if it's too much a statistic, I feel like for 5G people, I don't know. I mean, I have a lot of colleagues already in the call too. The connectivity part would be considered only a pipe, and that connects one asset to another. So there is not much dynamicity here, or let's say extra improvement needed from the 5G to fulfill what asset administration needs of today. It's just like a normal connection probably. But I mean, we can check this angle later on, because I think this second angle would be more difficult to proceed. But yeah, I need also to think more on that and check. Definitely.
The way,
Yeah, please.
sorry, just one comment. I was thinking that one possibility, because you wanted to use as a administration shell, maybe also as a configuration tool, or so. For example, an antenna, no, or an 5G edge, which controls you can use in the same way we are using for our industrial edge devices.
Exactly.
You could use it for the configuration or a common interface for this type of devices. Other option is, for example, if a robot has 5G as a capability, you could describe the 5G module in some way, and then it could be a submodule of the robot also. This could be other usage. But in both cases, you should always have another way to access this device, which is through the MQTT or something. But when you have an antenna, you always have another connection, no?
Exactly.
Or a 5G edge. Yeah. So
exactly. So, for example, let me just divide my my comment into one thing. First, you mentioned it is correct. Like imagine, so I have a robot, and this robot has dual connectivity with 2 SIM cards to an antenna, and it's a capability inside of the communication part of this robot, and it can be used, right? So it's one thing. It's very important thing, should be reflected in the communication model of asset administration shell. So the factory owner knows that the robot X is not only connected, but it also has dual SIM cards, so it has a higher reliability. I don't know, just inventing, right? So I think this is very valuable, and then we can try to configure XYZ. This is one thing. Another thing is like, now I want to run, let's say, an application of asset administration shell in the language of 3GPP on the 5G network that is providing coverage. Do I really need to change something on my network? Because it's very much demanding if it needs because it needs extra lower latency, or it has a huge bandwidth requirement, or it needs a sort of synchronization, or it needs something. I mean, so far what I'm seeing is probably the data packets that are communicated here are very small. There is no hard requirement of, let's say, packet loss, because, okay, doesn't matter that if the packet comes 1 single minute earlier or 1 single minute later. So far,
this could be a time-sensitive device, or it could be a camera which sends loads of data. This is
we can double check that later on. So far, I don't see much of implications from the use of asset administration on top of a 5G network. Probably 5G as it is okay for 90% of the cases. At least this is my initial, let's say, impression. But I agree with you. For 3.3, we should follow the first path mainly, or at least start with the first path, to reflect the capabilities of devices and enhance this communication line of asset administrative shell with 5G capabilities. This is what we need to start doing. And yeah, I think this paper also started doing this from their perspective.
Well, I think one good exercise for the beginning, I think, do you remember the second slide that we presented? Can you put it? With the cube? There is this cube that has different dimensions, no? The life cycle, hierarchy. So it's good mental job to work which cubes are for you to use, no? Because, for example, in the live product produce, plug and produce, we only use some part of this cube. So, and it's
imagine maintenance, for example. I mean, you have a radio head in your factory already installed. I mean, this might go. It's a device, right? It might the life cycle of the system might ends, and you need to replace the antenna by itself, right, after a few years. So this is something that it interests the factory owner to know. So it should be somehow reflected in part of this asset administrative shell. Yeah.
Each cube of this small cube in this big cube it could be a different asset administration shell, no, a different digital version, and maybe a first work could be to make what cubes make a sense of for the 5G. So we have like a list of all the different types of asset administration shell that make sense. Then you can focus on one or two. Or,
No, definitely. I agree
It's
with
no
you.
idea, just saying, giving a.
That's very good. That's very good. That's a very good idea. So let's maybe keep this as a cross WP4, WP3 conversation, and we can reflect this on 3.3. I agree with you. This is the first good step, and then we move forward with that. Yeah, I agree. Perfect.
Okay. I don't know if there is more slides.
Sorry. Okay, the last slide is about the links that you can hear. And the sample that we show about the robot, you also have this example here. If you go in ZeroSWARM, where are some other AAS file like the process and the product. So maybe you want to check and see with more time. And if you have any doubt, you can contact us, and we will try to solve the question that you have. Okay, so I don't know if any of you have another question or if everything is clear.
We went faster than expected, but no, so now we have more time for questions.
Yes.
Okay, since the other colleagues are a bit shy, maybe I can take the opportunity to thank you all. Thank you for the nice presentation, for showing us let's say different angles of this. I mean, at least for me, a new and complex world. I know that for you that is more let's say day to day let's say activity. 5G might sound more complex, but please put yourself in my shoes, and for me 5G is more trivial and this one is more complex. Yeah, so but I think, yeah, I mean, this conversation, negotiation, and let's say sharing ideas makes us all to better understand what is going on the other side, and better decide. And I think you guys did a fantastic job, and it opens up more door for let's say further conversation. Well, thanks a lot. So I think maybe, yeah, we can, if there is no extra, let's say, questions or comments, maybe, yeah, we can use the opportunity to, oh yeah, okay, I see a comment, please.
I will have a question. When you show the example of the AAX package explorer with the communication submodel, you said that this is an AAS of type 2, but you can use this AAX, this .aas file to communicate, or is only the serialized data?
As we said, the AAS of type 2 needs a platform, a software that enables the communication to be as AAS of type 2. So you need the AAS to serialize the data, and also the AAS to be hosted in a platform that enables the communication.
Type 2 or type 3?
Type 2.
So
type
for
3
example,
also need, type 2 also need.
Can you put one slide of the architecture? So.
One moment, please.
This one, yeah.
In this case, we have type 2 AAS because we also have a platform that enables the communication with the devices. Okay, so, and also type 3 because we have some software that enables the negotiation and the interchange of information and modify another asset with this software.
Yeah,
this is what enables the type 2 properties.
The edge devices in our implementation, also the asset administration shell configures the pipeline and the part of the pipeline are the communications. For example, OPC-UA, Profinet, and so on. So I don't know if this answers your question, but yes, you.
Okay, but you said that with a software to simulate a client OPSI UA, is this the solution, or I don't understand very well that?
Of course, you need an element that connects the digital part with the physical part. It is, no, for example, the device one, this is the physical part, but you need something that connects the digital part, that is the AAS model that is here. You need a software, something that understand that that make the connection between the digital with the physical. Of course, you will need some software, something like to make that connection.
Yeah, in our case, this edge computing software reads the asset administration shell and instantiates different communication and processing modules and connects them. So this software is because the asset administration shell is only a representation information model, but doesn't do any communication per se. You have to have another piece of software for doing so. This is what we.
But you also need those operations submodel and the capabilities submodel to do this.
Yes, to make the plug and play.
Okay.
The capabilities and the skills, what enables is to do the plug and play architecture.
In this implementation,
to automatize the elements.
In this plug and produce implementation, they use the capabilities to know which manufacturing cells can produce a specific product. No? The product tells them, I need this to be done to create the product, and the orchestrator, which is the intelligence, the type 3, finds which cells are capable of producing this product. So this is a complex usage of the asset administration cell. But if you only want to, for example, configure an edge, you don't need all this part which is for the plug and produce. You could only use it to configure the device. So the way you use the asset administration shell depends a lot on your needs, no? What you are trying to do. For example, if you only want to configure a 5G antenna, for example, you don't need all these plug and produce capabilities. I don't know if we answered the question, because I'm not quite sure.
Okay, in the case of that example that you said about 5G, you only need that OPSI UA or that MQTT, and you don't need that edge, or?
Can you go next slide? For example, let's the left top diagram. Let's think this is the 5G edge, no, a device to configure the 5G antenna, no, for example. So you should have an MQTT connection to, for example, read or write asset administration shell descriptions, and then you configure the 5G communication depending on this. For example, you don't need maybe the OPC UA, you have the 5G communication there instead of the OPC UA. I don't know if could you repeat the question on this diagram?
Yes. My question was that you have said before that if I only want to configure my 5G communication, I don't need the edge. So, or I understand that, but I only have to use that MQTT and that OPSI UA server.
No, to configure your AA, the asset of the 5G, I don't know which asset, the only thing that you need is the asset administration shell. Read the information in the asset administration shell and check all the needs that they are defined. You have to match the configuration which is defined in the asset administration shell and check that all the needs are complete.
You need at least one way to send the asset administration shell to the device to configure it. It can be an MQTT, OPC-UA, a web server, or whatever other option you choose. If you want to use the asset administration shell to configure a 5G network, I'm talking about.
Okay, I understand that. Thank you.
Yeah. For example, now maybe I don't know. For example, a router for your house has a web interface. Underneath has a software that connects to the hardware of the router. This software for us is our edge computing pipeline, which connects cameras, process data, and so on. So, for example, for a router, you could add a button in the website of the router to configure it through asset administration shell. And then you, from there, from your computer, you load an asset administration shell. It could be like that, or you can open an MQTT connection and do it from software automatically, remotely from other place or so. Okay. Hope I answered your question. It's very open. You can use it in the best way you want. In our case, we want to use OPC-UA as a standard for the real-time data, and that's why we put these drawings. But you could add any other type of communication you want to for connecting the asset administration shell, and also for connecting and reading the real-time data and so on. So this is an open discussion, and depending on your application, you have to maybe to change, to design your own architecture for your device. But yeah.
Roberto, just maybe one small clarification on this real time, which might help this conversation. So, what does this mean real time for you? I mean, let's put it like that. So, when we come from the background of mobile communication, real time for us is more like I don't know, a low latency, a sort of tactile internet. I touch here, and then the thing moves there in a matter of nanoseconds.
What I mean is manufacturing data, which is changing. For example, the pressure of a sensor. I want to see the pressure in a graphical interface, for example. So I publish this periodically into the OPC-UA server, and whoever wants to read this sensor is there. Information.
But then, so you're using real time against static data, as I understood, because a sensor might read something every 2 days. It's not necessarily.
Yes, I use
the real data that refers Roberto is the data in motion.
Data in move, okay. So,
I put real-time data.
Updatable data, basically.
Yes. To differentiate it from the configuration that maybe you put once. And
the configuration could be will be the data in rest, and the real data that is talking Roberto is the data in motion.
Yeah. So, for example, data in rest or configuration is a camera. I set up the exposure once, and then I get the real-time data or data in motion is the image itself. I want to see the image for this process, for example. Maybe this is a problem of the.
Yeah, I think there is a language gap here between the two sides, but that's why I'm trying to get a better understanding. So it could include very fast data traveling between point A to point B, but also can include data that is traveling from let's say device A to device B in a framework of week or a month. Still, it considered for you a real-time data because it's changeable data over the frame. Yeah, okay.
For us, real-time is well, this is a word which is has many meanings, because depending on the application, it can be 1 second or it can be milliseconds. I was thinking just maybe I put the wrong word. Maybe it's data in motion.
No, I don't think you're using wrong word. It's probably the same word has been used in other communities with different meaning. For example, I think edge would be also here a bit confusing, because probably for you edge is a sensor, is a screen, but I'm sure for those who are coming from the telecom background, probably edge would be meaning of mobile edge computing, which is a server. So I think we have this challenge also to.
For edge is that it connects to the cloud. For example, to differentiate it from a device which is only, for example, a camera which has no intelligence. The edge in our schema gathers data from the simple devices like a camera, robot, and so on. It's like an IoT device, but we call it edge just because it has the ability to run artificial intelligence.
It could be an IoT gateway, basically.
Yeah, it's an intelligent IoT gateway.
Gateway, okay.
With the ability to filter, no, because it has processing capabilities. Not only standardizes the data for the cloud part, but also does some filtering and processing of data. For example, maybe I don't want to send all the image. So I only send to the cloud I do the inference in the edge and send it to the cloud only the results of this. For example, the defects I found in this product I'm producing, for example. Can you go to the previous slide? You see the edge part, we put it in between the cloud and the devices, the individual sensors and actuators. So it's just like a computer which gathers data, process and sends to the cloud, and has this usually has the interface to the cloud, no?
And I think what Jorge was asking is like, is it like necessarily every time in every implementation in all the scenarios you need this edge blue layer, yes or no? And I think it depends on the scenario, because I think you guys were saying if it's just sending a simple configuration file to a radio device that sits I don't know somewhere, maybe you can just do it directly from MT2Q and you don't need this edge layer. But there are some cases that you might need the edge layer too. Yeah.
But in this case, if you don't have the edge layer, the device must have some intelligence to understand the configuration.
Exactly. So yeah, the device should be able to understand okay.
If you have that capability in the device, you don't need the edge layer.
Exactly.
So the edge layer
this architecture is flexible enough to reflect both options. So you can have devices that necessarily need this edge layer, or you might have scenarios that this is needed or not needed. Yeah.
Here the edge layer is exactly what you said. It's the glue to connect the asset administration cell to the devices itself.
And so this edge is as a translator, more or less.
It makes more than one thing, because it also joins data, standardizes the data for the cloud, works like an IoT framework, also processes the data. This is another thing that it does. And then does the asset administration cell part. So we can configure a full manufacturing cell just sending one file, no? Which is very easy. For example, I want to manufacture this product. I just send a file, and then all the devices are configured by the edge device using the respective protocols. For example, the camera, gigabit Ethernet, the robot, maybe a proprietary ABB or other company protocol, and so on. So,
but what you're saying is that, yes, at the end, it also translates all the information of the asset administration shell in a way that the device can understand. So you can have at the end, what the edge also does is to connect the physical part with the digital part. Okay, so if you have a little driver that does that, you don't need something more complex like we need, for example, in our process, maybe some driver that make the translation between the AAS and the device. It's the only thing that you need.
We selected this because our needs, basically, because we have manufacturing cells that we connect many devices, different devices anytime. So we would like just to have one piece of software, which is the edge computing software, which is flexible enough to cope with all these different setups. But at the same time, this makes complex for the developer to because he manually has to connect all this and understand all these blocks. So now we want to use Asset as a way to have just a picture for one setup. So we have the cell 3 manufacturing this product. This is one file. Okay, I send it to the cell 3, and then I have already all configured.
In your case, if you have something more simple, this, sorry, you can see my mouse, or more or less.
Yes.
For example,
Yes,
the
yes.
device N, if it has a driver that can can connect to the base to get the AAS configuration, the AAS model, and to translate. So in this way, the device N, it is smart, could connect with all the cloud in a layer. Maybe that's enough for you.
Okay.
But you have to check that your asset is intelligent. That's the only thing that
In the future, if this is a good big standard, maybe the cameras come with asset administration cell interface, and you can already load.
That was my question. How it is likely that a device nowadays come with an embedded I don't know, connector, reader, or how we can sell this element of asset administrative shell inside. I think it's very unlikely, right? It's not.
Very, very unlikely, I think. Lucia, maybe Lara can tell you better, but I've never seen one.
No, yeah. Nowadays, only some partners of the IDTA, the first, like Siemens.
No, Bosch, Festo, they are the ones that they have the
Germany companies.
They already have products that support this?
Yes.
Okay.
But only static information, documentation, this kind of information.
So it's not necessarily a full product yet out. It's more like a proof of concept and ideas that they're trying to do. Okay, it's very early stage, probably. Okay, nice, thanks.
And only type 1, no? You are just saying like?
Yes,
type 1.
They are using it as documentation and so on.
Okay, so it's not even yet in the mode of interactive, let's say.
No.
You cannot send to the robot and it already configures or something like that.
And I see also there is a question on the chat. There is one of our colleagues that says he's in there is a problem. It says, I want to ask about perspective of software tool support for integration into different standards. For example, the standards IEC 61499. Are you aware of this, or maybe we should start exploring about that?
With OpenCUA, we plan to open source our edge computing software. So this could be an implementation that can be used as a reference. For the 499, maybe the people who is working on that should comment. I'm not aware. No, you are not aware of.
No.
About the asset administration cell and OpenCUA integration, have you seen any jobs on that?
Yes, we have. There are. I think that Lucia put in the chat. I don't know, but there are some
Yeah, I also see, as Roy also put a paper as an example.
There is.
I think there is some early works, but probably it's not yet, let's say, product level ready, maybe.
Yeah, so this paper for the 499, it pays off to take it a look. Maybe it's an initial proposal for this.
Correct, thanks.
Yeah. For the OpenCUA, we are, as I showed you before, there are many options that you can do it. We will choose one for our edge computing framework that will do open source for the task 4.1. But there is not only one way to do it.
And I think Matteo from Nextwork also had a question, and then I see also Maria Carmen having her hand raised.
Okay.
Matteo, do you want to go first, or you're already out because he said he needs to drop off? Okay, seems Matteo is not here. Please, Maria Carmen.
Okay, thank you. We are working currently in the definition of the AAS for 5G. We are still in the first or second phase that you presented. We are thinking about what we need to include and in the definition first of a passive. Although our aim focuses to define an active AAS for 5G. And my question is about the software that you are using for the definition of the AAS, because we already are explore this AAS explore software, but we think that in some cases, if you want to do something more active, this AAS Explorer doesn't allow to do that. And we have seen also the software basics. I don't know if you know about this software.
Yes.
Yes, we are aware of that.
And my question is that you are only using the AAS Explorer, or you are actually working on basics or other
First, for managing all this information and for modeling, we develop a library from the, I will write in the chat.
Yes.
One moment.
E40 AAS, maybe?
Yes, I wrote in the chat.
This is a library that you have developed?
For managing the AES information and for modeling. Because if I want to create an asset in a real time, I need to do it in automatic way, not using the Package Explorer. So for doing that, we use this library as a basis. And then for the server...
But this library is developed by you?
No, this one is, I don't know who developed, but was not developed from...
Okay.
We didn't develop this library.
Okay.
We took this library and did our library. Because this is a very basic library. To read the AESX file or to write the file. But I want to manage the information. I mean, I want to create a submodel. I want to create a property.
Similar to the Explorer, no? But
yes, the problem that with the library you can work in an easy way in real time. So we develop another library to help us working with the as administration shell.
Yes, and this library that we are working on, this will be part of the toolkit of ZeroSWARM. And all of you will have access to this library. And for this is for managing the information and for modeling. And for the software part, we have, if you go to the structure, this own digital platform that we call Orchestrator, that is composed by an API and a MQTT broker and database. That is similar to the one that has developed by Basic. And in other projects that we are working on at administration shell, we have a partner that is developing this digital platform.
Okay, thank you.
You're welcome.
And I have another quick question. If you go back to the one slide that was about the skill and the yeah, that 4 boxes, if it's possible.
Sorry, I don't understand you.
There was one slide that was talking about the skill, capability.
Services.
Oh yeah, this the previous one. If it's the next one.
Or the next? The next. Okay.
So this is more about like from the perspective of a standardization, like who are the ones that are driving. So from what I understood, this type of drawing or kind of let's say unification is coming from the community of ID. What was it?
IDTA. Well, it's from the platform Industrie 4.0.
Okay.
You can find all these pictures that we present today in the documentation that is available in this.
These are mostly German manufacturers, no? In this.
Yes.
And then let's say the submodels that we saw, for example, from the communication and let's say other items, are submodels that goes under the capability and the skill so far, because as far as I understood, they are not thinking about, or they are not yet ready for services or PPR yet, right? So these are 2 boxes that are less developed, let's say.
Yes, but also they have the other submodels that they are not part of the capabilities and skill functionality, like the identification or technical data that contains the static information.
Okay, correct. So they have like some definitions on the static models, they have some on their capability, some on their skills, but let's say the part of service PPR is yet to be developed.
Yes, yeah.
Okay.
Okay, I don't know if there is another question.
So with the library that you mentioned before, have you already created some AAS of type 2?
Yes.
This? Okay.
Yes, we are using that library, and we create and work with AAS of type 2, and we also have one AAS of type 3.
Yeah,
and we are working with it.
The diagram we showed before is already working on a first
Yes.
implementation.
This is working.
So all these parts are more or less working. They for the edge part, they already have a Python code, and then for the which is called orchestrator core, which is from AIMEN, and then we are doing an alternative in C++ for the ZeroSWARM, which should be different architecture because it's the pipeline, but is more performance. And yeah, but the rest is the cloud part. They already have a fully working orchestrator with the database and web interface and so on.
And you combine this library with another software for the communication via OpsCUI or MQTT, or with this software is enough?
The software, the orchestrator software, of course, use the AAS library to understand the models, and then also it has implemented some protocols like MQTT to send the data to the broker or to wherever
and
it needs.
For the other devices too, for example, for a camera, you have an underlying library to connect to the camera. For Modbus, we use the pipe Modbus library. So the orchestrator core has like a software layers. It has like a device model, and each model inside implements their own communications to the physical device with their own libraries. to the top, it has the MQTT API to receive the asset administration shell. Well, it's a JSON, no?
Yes.
Yeah.
It is the asset administration shell. It is sent with a API REST communication in a JSON serialization instance.
Yeah, because the package explorer saves into a XML, no, and then it packs it everything in a compressed file.
The package explorer, when you use the package explorer saves the data in the special form of the AAS file. This file, this is a serialization of the AAS. The serialization can be also serialized like an X file and a JSON or OPC nodes or whatever, or automation ML, for example. You can serialize an AAS instance like with various format types.
May I ask another
Okay,
question?
thank you.
Just a small thing here. So how likely you see in this picture on the physical side mainly that you might have hierarchy of devices? So instead of like device 1 being connected directly to the edge, you might have, let's say, a hierarchy of devices connected to device 1 and then connect to the edge. Is it something that could be?
Yes, actually we have between the edge and the devices, we have another AES that represents the complete cell or the complete pilot, the line, sorry. And then this AES is composed by another AESs that are the devices. And this can be done using the AES modeling because you can reference these devices.
Yeah, so they are currently using this bottom right, this bottom right drawing. So they have all the assets modeled, all the devices, and then they create other asset for the next level of the cell, where they insert the asset administration cell of the devices as a submodule of this type, asset administration cell composition. No?
This is what we talk in the phase 0 modulation, that the granularity depends on what do you want to digitalize.
Okay, I understand. And just maybe one small question again to this picture that you are showing. I'm talking about the right-hand side below, the modeling at asset asset level. Yeah,
this one, isn't it?
So how or as far as you know, basically, how much do you think? Because let me just reformulate the question in another way. If we go back. So keep this picture in mind, and if we go back one slide backwards, so I understood that this edge is needed because you have something coming from the cloud side, that this edge, this orchestrate core, or let's say this edge, is kind of translating this word of AAS into something understandable for the device. This is one of the reasons, right? So this is one of the reasons.
Yes.
So how much you are aware that such a capability of translating AAS into something understandable for the device can be supported by the wired technologies, networking technologies, let's say natively. So what do I mean natively? Instead of implementing another layer of software, this could be part of an IEEE switch that you can buy, and then basically you just need to send your let's say cloud information to that switch, and then that switch also takes care of the translation. So it could be like a native support from the network. Are you aware of any directions like this or no?
You have to integrate this layer in the device, no? Or
in the device,
Yes.
exactly. So that's what I'm asking, if you're aware
there is
of.
no other option. You have to, the device internally has a representation of their parameters and so on. You have to translate from the asset administration cell serial file JSON or whatever to this internal like a parser, but it's more or less it's very easy.
Okay.
If you have a good internal representation of your device parameters, also in a, for example, in a tree like this, something like that, you could very easily map the asset administration cell tree to your internal representation. That's why I was saying maybe in a router you just add a button to load a configuration with the asset administration cell, and this button, what it does is just to parse this asset administration cell description to your internal representation of the router, and then just call to the reconfigure the full router or some part of the router, and that's it. So I think it's just adding a parser from the asset administration.
But what I was asking, like, so far you have not seen any paper or a standard touching about inclusion of this parser inside the router or the device, or maybe, I mean, just if you came across to such a thing so far.
No, for now, no.
Okay, thanks.
Yeah, I think this depends a lot on the device, and
because now, as Lucia has said, the asset administration shell, with, for example, with the assets of Fest or something like that, are using like AAS of Taiwan only for documentation nowadays.
Okay, thanks. Yeah, so
Yes,
it's
because
yeah, please.
they are in the phase that they prefer to focus on the modeling and to build this, let's say, common information model of these submodels. And when we have this finished, we will move to the implementation of the type 2 and type 3 asset administration shell. First, we have to work on the modeling, and this is where they are focused now.
Okay, thanks a lot.
Yeah, and there is a question in the chat. Where can we download the recording of this meeting and the PowerPoint? I think we didn't upload the PowerPoint, but we will do it at the end of the meeting.
Puria will say, no, in the workshops folder, nothing in the...
Exactly, it would be on the shared drive. So if you go to the next cloud of ZeroSWARM, there would be a folder called, if I'm not wrong, meeting, and inside the meeting there is so-called work package level, let's say, workshop or something like that, and this would be the work package. Sorry, it's not workshops. Sorry, it could be project level workshop or something like that. And this is the 5th one. This is the 5th edition of the project level workshops. Yeah.
And on Tuesday we have the 6th, no, about OPCV.
Exactly. So let me see if I can find the URL and then just copy paste it.
So on Tuesday we will be doing a smaller OPCV workshop, like an introduction, and also a live demonstration watching at an OPCV server. And with these two workshops, we expect we fulfill some part of the task 4.1. And so we can all better understand and keep working together. Sorry for the noise, we have an alarm here. I don't know if it's fake or it's real.
Okay, any question?
Not anymore from my side. I don't know if the other colleagues has any other question. If not, I mean, again, I would like to thank you guys for the very good presentation, for sharing all this information and answering our questions from different natures and different kinds. I know it's a bit sometimes difficult to put everything together in one single, but I think you guys did a fantastic, wonderful job, and it was super informative. I mean, thanks a lot. I mean, personally, I have learned a lot. So I don't know if other colleagues have more questions. If not, maybe we should call it a day and wish everyone a very fantastic weekend.
Okay. From our side, thank you for attending. And if you have any more questions, let's do it by email, or we do a meeting in the different tasks. And let's keep working together. I think is the best.
And thanks for being here and listen us.
Yeah.
Okay, so have a nice day and a nice weekend.
Yeah, have a wonderful weekend.
Bye-bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Bye bye.
Bye.
Thank you. Bye.
Bye.
Thanks. Bye.
So George should stop the recording, no? And you upload.
Yeah, I think I don't. Yeah, okay. George is now here because he wrote to me that he could not stay longer, and probably I am the host now. Let's see, or I'm the co-host. So let's.
But the recording stays in the WebEx in somewhere there, no?
I think so. So let's see if George is here, or if it's me to need. I could stop, or maybe something of the recording. Let me see if I can understand how to do it. Otherwise, we might lose, right? So let's. Okay.
I don't know. In Teams, there's no problem because it's saved in the.
Okay, it says recording is
Teams
in
cloud.
progress. It says recording is in progress. Open the recorder to manage recording. Okay, how can I open the recorder? Audio and video. Participant meeting. Let me see. Share view. I don't know. I mean, should we just close and it saves automatically, or?
I don't know, Puri. I don't WebEx. I don't use it.
Yeah, let me just drop a line to George and ask him. So just a minute. Yeah, if you guys want to go, I mean, feel free, because, well, I think I will keep the session open just to confirm that if I need to do something for the recording.
Okay, George is still here, so if,
yeah,
when he comes back, he will see, and I think properly close the meeting.
Yeah.
Because he created it, no? He is the one.
Yeah. I think they created the link, so it was.
Yeah. It says host, and you are co-host.
Yeah, I'm now co-host because he needed to go somewhere. He wrote to me on WhatsApp and said, like, I'm going for 10 minutes and I will come back, but I think he's not yet come back. Okay. Yeah, but feel free if you want to go. I mean, it's okay. I will just stay to make sure that we would not lose the video. So I will stay until George confirms that it's okay to close, or he comes back and he closes it properly. So.
Okay.
Thanks a lot. Take care. Cheers. Bye.
Bye.